Thank you all for coming to my session. My name is Maor Lipchuk. I am a senior software engineer in Red Hat Israel. I work in the oVirt storage team. And today I want to present to you what we did in oVirt 4.2 and how we basically support disaster recovery solution using Ansible in an automated way. So, first question that crossed my mind when I was preparing this presentation, can we really avoid a disaster? I know it's probably a stupid question, but basically every company, no matter how big it is, how money they spend on avoiding a disaster, encounter a disaster one way or another. I think the main strength of a company is to recover from it quickly and efficiently with almost no loss of data. So, saying that, let's talk a bit about oVirt. So I assume most of you know oVirt. It's a it's a virtualization management platform that helps admin to manage VMs, templates, and hypervisors, hosts. I want to talk about the evolution of backup and disaster recovery in oVirt and how we got to what we got in oVirt 4.2. So at the beginning, there are a few solutions for backup and recovery. I think that the most used one is the export storage domain. It's basically a file storage domain that was used to backup VMs that the admin saw as important VMs. It was a storage domain that was attached to the data center. The VM that was precious to this admin was basically copied to the export domain, the disks, and the OVF of it. And once it wanted back, want to use it after a disaster or after when he wants to use it again, he simply copied it back to the setup. So this is great for a backup solution, but it's not really efficient for backing up your entire setup. You can't really get your entire setup into one storage domain. Copy operations are pretty heavy, and that basically makes it that basically makes it a bit not really suitable for recovery. Sorry. So in oVirt 3.5, we introduced something which is a bit newer and can provide us a solution for disaster recovery, which are basically two features, which are OVF store disk and import storage domains. With those two features, basically what we did is that we took the storage domain, and on each storage domain, we have the disks, which are the VM's disks, the metadata of the storage domain, and we introduced a new special disk, which was called the OVF store disk. What the OVF store disk is basically contains is that each VM is represented by an OVF. This is an example of an OVF. It's an open virtualization format. It's an XML that represents the VM, the metadata of the VM, and with that OVF, with the disks which are assigned on the storage domain, we can basically recover all the VMs and the templates of the setup. So, sorry. So, basically, the storage domain encapsulates somehow the data center, or you can get only storage domains, and with the OVF store reside on them, you can basically have all the information to recover an entire setup. So the improvements, of course, is the recovery process is pretty fast, because now the OVF store contains all the OVFs, and there are no any copy operations need to be done. All the VMs and the templates in the setup are basically recoverable. So now you don't have to back up your entire data center. It's basically all there. oVirt does it for you. But still, it's not really a fully fledged solution. It's not an end-to-end solution. The admin still needs to orchestrate the recovery process. It needs to import all the storage domains. It needs to register the VMs, the templates. Some mistakes could be done on the way, and probably failures could happen. And if you want to recover as fast as we can, still it's not there. Second of all, the OVF is a great way to know all the data of the VM, but there are still gaps there, still missing parts, like, for example, permissions and the cluster name of the VM, which was before. So even when the admin tries to recover the setup, it still needs to fill in all the gaps there. So it's still not enough. Okay, so saying that, let's see what we did in oVirt 4.2. So first of all, we were trying to fill in the gaps. There were a few gaps that were missing from the OVF, as I said before. I won't go to each one of them, but we were trying to see what is missing and what we can add in there. As I said before, like permissions and the cluster name. So, for example, we added the cluster name. Before that, the admin, when he wants to register a VM, he needs to explicitly indicate the cluster that the VM should be registered to. And now, basically, if he knows and guarantees that the cluster is already there, he can do it really automatically. He doesn't need to do anything. So it makes his life a bit more easier. Second of all, what we added, when we talk about disaster recovery, what we want to gain is that to get the destination setup after a disaster up and running as fast as we can, and then with the same state as it was before. So for that, we also need to preserve the VM statuses. We probably had VMs before that were running that were probably very important for the admin, and we need to have a notion which VMs were running before. Those type of information is not typical for the OVF. OVF needs to gain the metadata. So what we did is that we added in the OVF store disk, in this special disk, we added a new file that will be some kind of extra data. Part of it is also the VM statuses. So every 60 minutes or every few times that you configure, all the data in the data center is being preserved in the OVF store disk, and you can know which VMs were running at the time when the data was backed up. So basically the admin can know after recovery which VM was up and running and decide whether to run it or not. The third thing which we basically did in oVirt 4.2 is not really a new feature, is some kind of a defined way for the admin how to make his environment ready for recovery. We defined a way to support recovery process using a separate oVirt setup. And now I'm going to show you what were the pre-requirements for the admin to basically get his setup ready for disaster. So first of all, storage replication. As I mentioned before, storage with the OVF store disk basically encapsulate all what is in oVirt, basically, mostly the VM part, but those are the most important for the admin. So the admin needs to support a replication from its storage domains to another site that in case of a recovery can use those to import to another site. Second of all, prepare a just-in-case setup. the admin needs to have a secondary setup up and running because we want the recovery process to be fast as we can. He will add their clusters, hosts, running hosts, and the replicated storage domains will not be part of it yet, but in case of a disaster, the idea is that it will import all the replicated storage domains in the in the secondary setup, attach those, register all the VMs and the templates, and run all the VMs which were running in the original site. That way we can gain some kind of recovery that is better than it was before. I know the third part is marked with red, and I will get to it in a few slides. So, after all, this is how it will be done. The primary site will be disabled, basically, and the secondary site will be active with attached storage domains. So, as I mentioned before, there is the register of the VMs and the templates, but there is a problem here. The problem is that the OVF is updated with the primary site. The primary site has different clusters, it has different permissions, it has different networks, and the user needs to make some changes in the OVF for them to be registered in the secondary setup. So he needs to basically choose which cluster to use when you register the VM, for example, an alternative cluster or a different affinity group or different permissions. For that, he needs to prepare a mapping file. So what the mapping file basically does is that the user will use a pre-configured mapping file that will say, when you get a VM with OVF that define permission or cluster, which his name is A, in the secondary setup it should be B. Using this mapping file with the register operation, this is done automatically. That's basically what needs to be done. So writing these mapping files could be exhausting. User needs to go over the entire primary setup. He needs to take all the cluster names, take all the users and the roles and the networks, and write them down, and then map them to secondary setup. This could be a long operation for him, and could be exhausting. And that leads me to the solution of Ansible. What we introduced in oVirt 4.2 also was a new role, which is called oVirt Ansible Disaster Recovery. You can look into it in the oVirt Ansible Galaxy. It's a role which is part of the oVirt Ansible repository. The oVirt Ansible repository basically gives various parts of oVirt infrastructure that can be used with oVirt in an automatic way. What oVirt Ansible Disaster Recovery supports today is the generate mapping operation, which basically generates the mapping based on the primary site and give you a type of a template that only the secondary and the target properties should be configured. It also supports failover in case of a recovery, do it really automatically, an end-to-end solution, and the failback, that once the primary setup is being recovered again and the hosts are up, probably the user will want to go back to the primary site because it has more resources, more computed resources, better hosts, better storage domains. Okay, so let's talk a bit about what the mapping generator does. So the mapping generator, as I said before, it goes over the entire primary setup. It creates a mapping template automatically. And what the admin needs to do is only to add the missing properties. This is a snapshot of the mapping generator. I will show you a bit more in a demo in a few minutes. As you can see here, this is created automatically, and what is in color there is something that the user should add. how the user can generate the mapping automatically. After it installed the oVirt Ansible disaster recovery and has the role, it needs to define a play, which is pretty easy. You just need to configure the site, the username, password. The var file is basically the output file, which the mapping should be done. The mapping should be provided. And the roles, we specify the role name. Then what it needs is a simple command, not something too flashy, just Ansible playbook, the play which you defined before, and tags to indicate, to generate the mapping. Okay, so after that, we got the mapping file. We have a secondary. Hello? Yeah. So after you have the secondary setup running, you have the replicated storage domains, and you have the mapping file already configured and generated. Now you are ready for a disaster. So what happens when a disaster actually occurs? So for that, we have the Ansible failover. The Ansible failover basically recovers the secondary setup automatically using the mapping var file as we've seen before. What it actually does under the hood, it imports the master storage domains first, then it imports all the storage domains, all this is done automatically, register the templates, register the VMs, then it first runs the highly available VMs because we can't be sure how computed resources we got on the secondary site. It's only a backup setup. And then it runs all the other VMs. To do that, just need to define a play as we did before. Really not something really complicated. We indicate the target host. It's the secondary, the primary, the source map, which we need to use for the registration of the VMs and the templates is the primary. We add here in the var file the mapping, the generated mapping file which we added, and the role. As I said before, just a simple command, and it works. I would like to show you a demo. So you can see here at the top, that's the primary setup. We have a running VM there. At the bottom is the secondary setup. No storage domains are attached there. So here you can see the mapping. This is, for example, role mapping and the storage domains, which part of there are the primary site and the secondary site, the LAN mapping. Here, for example, I wanted to show how we use some kind of a role mapping. We added the primary name of a user role, and once we register a VM with this permission of user role, it should be mapped to cluster admin, just to show that done automatically. So we run a failover. I already predefined this play. The Ansible is running automatically. We first attach the storage domains. So as you can see here at the bottom, you can see the storage domains being attached. And eventually we register the VMs and the templates. So you can see here that we refresh, and now we see one VM. Now we see the second VM, and the VM is running because we knew this VM should be running. And Just to see here, I'm not sure if you can see that, but here you see the permissions there of the VM in the primary site and the VM in the secondary site. And the role was basically switched from user role to cluster admin as it was before. So this was just some kind of demonstration of basically how automated it is. The admin doesn't need to do really anything. It makes his life pretty much more simple. Okay, so as I said before, once the recovery took place and the secondary site is running and we have all the VMs are running and everything, the admin is still working on that secondary site. Still do changes which are uploaded to the oVirt store disks on the secondary site. And eventually he will want to go back to the primary site. His primary site probably has more strong resources. And we need to support all the changes that was done on the secondary site that will be also applied on the primary site. So for that, we added a failback operation, the failback to be used with Ansible, with oVirt Ansible disaster recovery. The process here is that it gets the primary site ready for import. That means that basically it cleans all the inactive storage domains to be imported again. Then it cleans the secondary site. This is being done by moving all the storage domain to maintenance, detach them, and remove them basically from the secondary site. Then it noticed the admin that he got the secondary site cleaned, and now the replication needs to be switched. The primary site, the storage domain on the primary site needs to know the changes that was done on the secondary site. Once the admin say, okay, the primary site storage domains are updated with all the changes, the same operation of the failover is being done again. That means that the primary site storage domains are being attached again to the data center. We register all the templates and the VMs with all their updated data that was done on the secondary site. And we run all the VMs which ran before. First the highly available, and then all the other VMs. So, that being said, we now have an automation solution for DR with oVirt. We still got some gaps to fix and gaps to look forward to. First of all, we want to manage the mapping var files for oVirt UI. It will be much more easier. Now it's being used in any file editor. We want to fill in all the remaining gaps there in the OVF and whatever it needs. And we also want to add Ansible a bit more functionalities like add missing roles or users in the secondary site. And that's also some kind of future plan that we are looking forward to. So, for a summary, we saw that the OVF contains now more information about VMs and templates. That gives us some kind of a way that we can support all the changes and recovery, which is more reliable. VM statuses are now part of the recovery process, so we can know which VMs were running before. The admin has more strength to decide which VMs he wants to run again. The recovery process is being automatic using Ansible, which makes it much more reliable and easy for the admin to manage. And we added the failover and the failback of oVirt environment to basically give some kind of defined process for recovery solution. Yeah. Those are the links. A few of them of the Ansible Galaxy, the oVirt Ansible repo, and the oVirt Ansible disaster recovery repo, which you can see on GitHub. Yeah. that's about it. Are there any questions or comments? Yeah. Okay, so if I understand correctly, the question is what are the time between each update, each backup of your data to the OVF store disk? That's what you're asking, right? Yeah, so, okay, this is a configurable amount of time, which by default is 60 minutes. You can change it basically. It's configurable and can be changed. You asked also something about what happened when, for example, if I understand correctly, if you back up and then you made changes and the disaster occurs, right? Yeah, so in that case, basically it won't be recovered by the last minute or last second. You will have some kind of a gap of probably, I don't know, few minutes, depends on how you configure it. It's understandable, and basically it can be configured to be less minutes. But that will reflect basically on oVirt and how it works, because each time it will need to upload the data to the storage domain. Yeah. So it's a gain and lose situation. Thank you for the question. Yeah. Yeah, so you're saying that the VM which is running will not be recovered. That's only for the metadata. The VM will still lose its. It's not like it's not like live migration, for example. That's what I mean. Yeah, that's right. Thank you. Any other questions? Yes. Okay, so the question was that it was related to the process that was being done on the recovery, and that we first run the highly available VMs and then run the other VMs. And what you mentioned is that there can be some kind of a problem if there is no enough resources to run the second VM and the first VM is running. So it could be problematic for the whole process of the setup. Am I right? Okay. Yeah, so for that, basically, it's the admin responsibility to have those kinds of resources pre-configured on the secondary setup. I know that for a backup setup, it's really shame that you will have some kind of hosts that are running and doing nothing and just waiting for a disaster to occur. But if you're running really highly available VMs, if you're running really precious VMs that you must run, then I suggest that the admin really needs to guarantee that those VMs are capable to be running there. Yeah, I mean, we don't really guarantee that. The admin needs to guarantee it himself. Yeah, of course. There is, you mean the highly available and yeah. Yeah, that's what we do. Any other questions? Yes. I'm not sure that I heard the second part. Yeah, so for Rusted Engine, we are basically working on it. It should be supported, but the storage domain of the hosted engine will be only dedicated to hosted engine. So we support this kind of support. So basically, for supporting hosted engine, you will need to have a pre-configured hosted engine on the secondary setup, and the storage domains. The whole process will be done basically agnostic to the hosted engine. It doesn't matter because the engine is already running, and you just import the other storage domain and register the VMs and the templates. So that's the use case which basically should be supported. Any other questions? Okay. So if you remind of anything, feel free to come by. Thank you very much.